Ladies and gentlemen, here we go. In section 2 of chapter 2, we're going to talk about continuing our discussion from class about slopes and from algebra 1, how you find the slope, rise over the run. But we're going to talk about now specifically parallel lines and their slopes, how they relate, and perpendicular lines and their slopes, and again, how they actually relate. So let's dive into this. I'm excited. You ready? Here we go. All right, so here's the question that's being posed to you. Tell whether the lines here are parallel, perpendicular, or neither. And here's line number 1 you can see. Here's line number 2 with the actual point. So the line would go through 3, 2, 1, 5. So there's one line. Negative 1, 6, 2, 8. There's another line. Now you could certainly take a coordinate plane and graph these things and figure out, oh, they look like the parallel. Oh, they look like the perpendicular. You do not do that. The only way that you can verify for sure if these things are parallel, perpendicular, or neither is you have to use slope. So let's first of all though talk about this. What does it mean back from good old geometry for lines to be parallel? What does that actually mean? Well, lines parallel, remember, is this. They actually go on forever in two different directions for sure, but parallel lines are two lines that keep on going forever and ever and ever and ever and ever, but they never, never, never intersect. These guys here, not parallel lines because they intersect right there. These guys are parallel because they never intersect. Well, that leads to this then. If those things are parallel, what in the world does this word mean from geometry? Perpendicular. What does that mean? Well, remember, the definition of perpendicular is it is two lines, rays or segments, that they actually intersect very specially, so much so they intersect to actually form a right angle. So this being a line, this being a line, this being a line, and that being a line. So those two lines there, by definition, would be perpendicular. So we're talking about the slopes of these parallel lines right here and the slopes of these perpendicular and actually how they relate. So the slope of this one compared to the slope of this one. The slope of this one compared to the slope of that one. That is the general idea. So let's go. So what you see basically here is you can jot a nice little coordinate plane real quick on your notes. This is the scale. It goes 1, there's 2, there's 3. You can see it, there's 4, so on and so forth. I put a dot over here, and that dot right there happens to be at a point, a coordinates, whatever. I put negative 1, 3. So that ordered pair right there is negative 1, comma 3. And this one right here is actually 0, comma 1. So when you're doing that in your notes, 0, comma 1, that's ugly, sorry, is your 2 points. So let's go back here and actually find the slope of this particular line, and we're going to use that to figure out what the parallel thing is, what the perpendicular lines are and their slopes, and how that all rolls. So let's cut back and actually do this one for the actual slope. So again, it was negative 1, 3, I do believe. Negative 1, 3. And the other one was, I believe, 0, 1. So if I'm going to use the slope formula, which is right above here, I'm going to take y2 minus y1, so I'll go 1 minus 3. That's my change in my rise, my change in my y. And then I'm going to take 0, going in the same order, minus, ooh, careful here, it's actually minus a negative 1, so it looks like this. Ooh, look at that. So I go 1 minus 3 on the top, that gives me negative 2, and then 0 minus a negative 1 actually goes to positive, positive, which means I just have a 1. So the slope of that particular line that I had back there in the previous example is negative 2. So I'm going to go down 2 units, and then I'm going to go to the right 1 unit. And I'm going to go down 2 more, and I'm going to go to the right 1. That's what slope is. Down 2, right 1. Down 2, right 1. Down 2, right 1. So let's cut back to that. So check this out, because I think I can actually do this. Let me show you the actual slope. I think I can. Yeah, cool. So here you go. So you can actually see, let me take this off of here, actually make it so it's not so weird. Okay, so we see right there that the slope of this line, AB, is exactly negative 2. Now here's the thing. On your coordinate plane, draw a quick graph of another line that's parallel to this line AB. And here's what it looks like. Draw it over here to the left. It really doesn't matter, but I'm being specific so you can see the example. And here's the actual point. That point right there, this line that's parallel to the blue one. Now you can see they're parallel because they're never going to intersect. The question is, what in the world would the slope be of this green line? So what is the actual slope? Well, let's actually calculate it and see how this comes about. This point right here again would be negative 3, positive 3. So let's cut back and write that. So my example, I'll use a different color, is -3, +3. And then my other point down here I'll use, right there, is -1, -1. So let's do that. So that's -1, -1. So I'm finding the slope of this line. Well, let's use the slope formula. So x2, I did it again. x2 minus whatever x1 is. I keep saying that. Stop, Mater. y2 minus y1. There we go. All of that over x2 minus, oh, here's another tricky one, minus -3. Because again, it's always subtraction in here, always subtraction. So whatever x1 is, you got to plug it in. x1 happened to be a -3. So when I calculate this, it gives me -1 minus 3, which gives me -4. And then -1 minus a negative, ooh, check this out, gives me a +2. Wait, we can reduce that. -4 over +2 gives me -2. Whoa, check this out. Those two slopes appear to be exactly, oh yeah, the same. Well, let's go back to this and actually see, because I can calculate this. You know I did it last time, so let's do it again. And check this out. Oh, yeah, buddy boy. I'll change this so you can see it. Whoops, sorry, I went too far. Sorry. Oh, boy. There we go. So you can see, check that out. The slopes are exactly the same. So I just taught you something that is extremely crucial, and you need to write this down in your notes. Highlight it, star it, because it's one of the things that needs to pop out of your notes. So here it is. You ready? If two lines are parallel, then their slopes are exactly equal. Now, if you had to determine if two lines were actually parallel, what you would do is find the actual slopes of the two lines, and then if they turn out to be exactly the same, not like a little bit off, they have to be exactly the same. Well, then you know the lines are parallel. So there is big deal number one. So let's go now to big deal number two. And big deal number two is this. If I actually take, let me get rid of this thing, I don't need it. So let me take this original line, which is the blue one. And now if I drew a line that's perpendicular to that one, so do it on your notes. And here's a scoop. I'll actually show you. I'll give you the actual measurement. I'll show you exactly that it's 90 degrees. There you go. So you can see it's exactly 90. I'll change this to a simple one. Beautiful. So that measure GBA right there is 90 degrees. The question isn't if it's 90. The question is what's the actual slope of this perpendicular line right here compared to the slope of this particular blue one. Well, we know the blue one's -2. We got that. Well, why don't we do this? Here's a point G. It's at 2, 2. And here's a point B that's at 0, 1. Let's cut back and actually find the slope and see how it compares to -2. So the first point is 2, 2, and the other one's 0, 1. Here we go. Come back to this. Let me change colors. I'll go green. Oh, yeah. I'm going green. Environmentally friendly. So I got 2, 2 is one of my points, and the other point was 0, 1. So let's use the slope formula. y2 minus y1, y2 minus y1. All of that over x2 minus x1. Looks like that. So if I finish this up, I get -1 on the top, and I get -2 on the bottom. The negatives cancel out, so I'm left with just a positive 1/2. So the slope of that perpendicular line is 1/2. How is that compared to these two slopes, however? Whoa. Do you see it? Do you? Look a little closer at your screen. So the parallel lines that we found before was -2. This slope right here we found is 1/2. What do we know about these two slopes? Bingo! Bada bingo! You got it. They are opposite reciprocals. Reciprocals. Beautiful. So there is your key thing about parallel lines, perpendicular lines and their slopes. So back to this, let me show you the slope. So if this thing right here, if AB is actually -2, and we just showed you that, AB was -2, I better get -1/2 over here, a positive 1/2 for this parallel line, perpendicular line. I keep saying the wrong words. Come on, get them right. This perpendicular line better be positive 1/2 when I find the slope of it. Let's see. I'll find the slope. Ooh, looky there. So the slope of BG, that line, is positive 0.5, which is 1/2. And bam, there you go. Now check this out. As soon as I change the degree of 90, if I change that 90-degree angle and say make it a little bigger, let's say I make it 117. So now you notice that these lines are not perpendicular. But notice, one slope is -2 and the other one's -0.01. Actually, it's almost horizontal. Let's make it a little different. There. So notice this. These two lines are not perpendicular. Therefore, the slopes are not opposite reciprocals. The only time that these things are going to work in terms of perpendicularity is if you take this, let's make it 90. There we go. It was weird. So it's 90 degrees, and notice their slopes are exactly opposite reciprocals. So this needs to, again, be highlighted, starred, circled, big time in your notes. And here it is. If two lines are perpendicular, then their slopes are opposite reciprocals. So, let's go back to my example. Tell whether these lines are parallel, perpendicular, and either. So this is your CPQ question, by the way. Haha. So what if we do this? Well, you're going to have to. It's what you got to do. So find the actual slope of line 1. Find the slope of line 2 and determine whether these things are parallel, perpendicular, or neither. Remember what the deal is. Whether they're parallel means something about their slopes. Perpendicular means something about their slopes. Good luck. See you on Monday. Rockin', or whatever the next day of class is. Doesn't have to be Monday. Why did I just say that? Don't know. And let's practice these bad boys in class and we'll master them. See ya later.